Welcome back, Math 20-2. Today we're looking at quadratic functions once again, as this is our quadratic functions unit, but we're also going to look at analyzing graphs using this equation here. Now we've looked at this equation before, our general equation. This is our general equation, it's the most common. But this equation here that we're going to look at today and focus in really heavily on can help us with many different types of problems and help us understand the graph a lot more. It may also help us draw the graph a lot better. So if we look, one commonality between these two are the a's. A in here is the same as there. Okay? X and y are always common because x is your input variable and y is your output variable. So those are always going to be the same. But our other constants are different. Here we have b and c, here we have h and k. Now those constants have different labels for a reason. The a is going to be the same. This value a here is the same value as a there. And just for review, we're going to look at what that a value does. If you remember from before, if a is less than 0, that means our graph is sad. We have a sad face because he's negative if he's less than 0. So it's sad. Our arms are down and we're sad. We have a frown. Now, if you're sad, there's only a maximum what you could do that day. So sad face has a maximum point, a maximum of what they can do that day, right? So you don't want to get up. There's a maximum how high you can get. Now, if a is greater than 0, we're positive people. We are happy. We're ready to go. We are happy. We're good to go, right? So we're energetic. We're happy. We want to get up and do stuff. There's only a minimum of what you could do that day. The sky's the limit for what we can do, but there's a minimum of what we could do, and and there is no max. We could go on forever. So the minimum point is for that. Now, the minimum point is right here. Max is there. That's a unique point, isn't it? The vertex is going to be our maximum or minimum point. So that is also our vertex. Now, one other thing neat about the vertex is the y value is going to give you your max or min, and the x value is going to be what is the x value of the vertex going to be? If I look at this, I have a line going straight down. That is our axis of symmetry. Okay? So instead of this investigation here, I'm going to start off with something over here. Okay, so here we go. We have a formula, and we have these two elephants. They're on skateboards, as we can see, and here's their formula. Okay, it says y is equal to x squared minus 6x plus 10. So that's the formula for their half pipe. Now they want to know what is the minimum height and the vertex of the skateboarding elephants. Well, here we have in that formula there, we're using this formula, which is very similar to the formulas we used before. This formula here is similar to formulas that we've been looked at before. Now, I already give us the vertex here, and we're going to see a problem. If I look at this, here's my vertex. My vertex is 3 and 1, and my minimum height is 1 meter, which is the y value. Now that's very difficult to find using this formula. We have to do a bunch of math in order to solve that, don't we? Well, and there's the problem. So now we're going to go on to, I have a little secret for you. And here is my secret. So I have a secret about a vertex. I want to see if you can figure out this secret. Now, all of these, here we go. I have this equation here. If I look at this, we go back down here, my h is 1 and my k is 1. Okay? So that's what we're looking at. And a is 1 as well. Okay? Now, look at this formula here and how it relates to that. And now here is my vertex. Okay? So here's the formula again. Notice it's in this form. And here is going to be my vertex. Take a look at another one. And here's my vertex. For all of these so far, a is equal to 1. Here's another one. And my vertex. Still, a is 1. Look at how is this related to this formula? Well, how is my vertex related to my formula? And notice my formula is in this form. If we look back to this one here, with the formula in this form, there's my vertex. There wasn't much of a relation. But here you should start seeing a relation. Now, Here's one more. This is a tricky one. X squared is really x minus 0 squared plus 0, if you want to put it in that form. And what do you think the vertex will be? I think we're getting it. But now what happens if we change A? Look at that. We have negative 22 in front for the A. Will that affect my vertex? Maybe, maybe not. Are you on the right path or are you not? Let's see. Now here's my last one. We have another vertex. This one, or another different A, which is positive. How does it affect it? Interesting. So, can you figure out what my secret is about the vertex? I want you to pause right now and see if you could write down on how you think this equation relates to the vertex. Okay, let's see if, you have this right. Oh, I can't go down right now for some reason. Sorry about that. Here we go. So now, let's take a look. What do we think this h and everything is equal to? So if I take a look at this, my k represents the y value of the vertex from what we found out, and my h represents the x value of the vertex. Okay? So if we take a look at this, at each one of these equations, we end up looking at it, and that is true. Look at that. Negative 2, because if I subtract 2, I'm going to get that, and we get negative 2. Look at how all of these work. So it works nicely. See how that works? So 3 is in for h, and h is 3, minus 3, and k is 4. Perfect. And the a value has nothing to do with our vertex right now. It only tells you if it's going to be a max or minimum, as I talked about earlier. So if we look at this one here, this is a neat one. It's plus 2, x plus 2. Our formula is x minus h. So I have to put in a negative 2 in order to get that. Because if I subtract a negative, the same thing as adding. So h was negative 2. So that's why my vertex is negative 2. So as a quick review, right here, if a is negative, we're going to get a graph that's a frown, right? We know that. And the highest point in this one is going to be at the vertex. So this guy's highest point being shot is at the vertex. Just like here, the highest point of the angry bird being shown up is the vertex. It's his maximum. And down here, if we look at this lady here, her vertex on the swing is the lowest point. Is the part where she's closest to the ground will be her vertex. Okay? So now let's get back to our lesson right here. So we've already did a couple investigations there in a row, and we found out what the values of a, h, and k have to do with the vertex. Okay? The only other part we have to look at is axis of symmetry. Well, if I'm looking at this, h is my axis of symmetry. Okay, so that's one thing you have to know. And A determines if we're opening up or down, like what we looked at before. So here we go. Question number 1. It says, state the coordinates of the vertex of the graph given this equation, and so A is state the coordinates of the vertex of the graph, So as we take a look at this, we have x plus 6. And my formula is y is equal to A, x minus h, squared minus 9. Well, I have plus 6. So that must be x minus negative 6. My h is equal to negative 6. So I have negative 6 for my vertex, comma, negative 9. Okay? Then it says state the equation of the axis of symmetry for the graph. So the axis of symmetry is my x value, because my graph is going to look something like this. We know it's positive because of the 2. So my axis of symmetry is the x value of my vertex, because it's a straight vertical line. So that is where x is equal to negative 6. Now it says, does the function have a maximum or minimum value? Well, since it's positive, we are anxious, eager to go people. We only have a minimum of what we could do. There is no maximum, so there's a minimum value. Okay? And the value is at negative 9. So y must be greater than or equal to negative 9. Okay? Now it says, state the domain and range of the function. my domain is easy. Domain for any quadratic is, we're going to look at x such that x is an element or x belongs to all real numbers. And we want to look at y, my range is looking at y such that, well, we have y must be greater than or equal to, what is it? -9. Because that's my minimum. And y is an element of all real numbers. Okay? So determine the y-intercept of the graph. Now, how do I determine the y-intercept? The y-intercept, if I look at my axes, is this line here, and that's when x is equal to 0. At this line here, my x value is 0, no matter what. No matter what, here, x value is 0. So I'm going to put in 0 for x. In my formula, y is equal to, let's see, 2, and we have 0 minus or plus 6 squared, subtract 9. Well, 6 squared, so it's 2 multiplied by 6 squared is 36. Subtract 9. 2 multiplied by 36 is 72. Subtract 9 is 63. Okay, so my y-intercept is 0, 63. So my x value must always be 0. All right. So here we go. Let's take a look at this next part here. It says, in each case of the graph, given the number of x-intercepts, state possible equation for this. So it just wants one possible equation. Okay? So if I look at this, it says we want 2 x-intercepts. So if I have this, I could either have a graph that looks like this, where a is negative, or I could have a graph like this, where a is positive. Okay? So let's first look at a positive one. If a is positive, so I'm going to say y is equal to 2x minus, well, my x value doesn't matter for this. I could have it here or here. That doesn't matter. X minus 4, I'll say, squared. But now my h value, my h value doesn't matter. But now my k value does matter. So does my k have to be positive or negative? If we're smiling up, if I'm positive, my vertex is over here, which is above the x-axis. If my vertex is above the x-axis, will it ever intersect? No. So my vertex, if a is positive, my vertex must be below the x-axis. So I'm going to have -3, let's say. So I just want a negative vertex. Okay? There we go. In this case, we want a negative minimum. So then we have 2 x-intercepts. Okay? If I used a negative here, if I said -2, then this would have to be +3. Because if it's negative, we're frowning. And I look at it, my vertex should be above the x-axis. Okay? In order to hit twice. Now it says 1 x-intercept. Okay? So my graph could either look like this, or my graph could end up looking like this. 1 x-intercept. I'm going to do the negative one for this one, -3. Okay, so now I'm going to have x, and I'm going to say +2 squared. My h value has no implication on this, but my k does. But now what is my k going to have to be? Well, my k value, so my y, my vertex, must be 0. Must be 0 height, so it's hitting at my x-axis. My x-axis, my height on that graph is always 0. So I don't add anything. I just leave it like that. There we go. Now the next one is no x-intercepts. Well, no x-intercepts. I could either have a graph that looks like this, which is a happy, or a graph that looks like this, a frowny. Okay? So let's take a look at this. I'm going to do again positive, because I'm a positive person. I like being positive. So we're going to look at, we have y is equal to 3. Okay, a is positive. Now, if a is positive, let's look at a positive graph. A is positive. How is this going to work? We have x. H doesn't matter. I'm going to say -10. Doesn't really matter. Just shifts it over left and right, my vertex. But now, my k does matter. Does it have to be positive or negative? If I'm negative, I will have 2 intersects. If I'm positive, I will have none. So I'm going to say +9. Oh, and that's squared. So that's a sample equation. Okay? Now, if I wanted it in general form, to make it a quadratic, all I would have to do is, let's say this one here, if I wanted this in quadratic form, all I'd have to do is multiply this out. So I'd have negative 3 multiplied by x plus 2, bracket x plus 2. So this is going to give me negative 3. X times x is x squared, right? X times 2 is plus 2x. And we have 2 times x is plus 2x. 2 times 2 is plus 4. So I continue this, I'm going to get negative 3. And I get x squared plus 4x plus 4. I get negative 3x squared minus 12 minus 12x minus 12. So I look at this, this is very similar to the general form, which we have done many times before. So really, we could always convert this equation here into that equation there. Okay? So here is just a quick review before I send you off to do your assignment. It says, the coordinates of the vertex are always, just going to go here, coordinates of the vertex are always h and k. Okay? If a is greater than 0, the parabola opens. Well, if a is greater than 0, it's positive, it's happy. It opens up. You want to get up and do stuff. And the vertex is the, well, if we're positive and happy, there's only a minimum of what we could do, so the vertex is the minimum. Okay? And the range of the function is y must be greater than or equal to k. Because it's going up. Y is always bigger than the minimum. We're going up, up, up. Now, if a is less than 0, we are sad. We feel like going down. So our parabola opens down. We're downwards. We're negative. And the vertex, well, there's only a max I could do today. I don't feel like doing much. I just feel like going down more. So the vertex is a max. And we look at this. Y must be less than or equal to k, because we have to be lower than our vertex. Okay? And the domain of every function, a quadratic function, is x is an element of all real numbers. And the equation of the axis of symmetry, well, x is always equal to my h value. H. And that's it. So I hope you understand this. I'll see you tomorrow as we tackle the assignment together. Make sure you have some questions for me to ask, to clarify things up as we work on the assignment tomorrow together. Good luck. See you tomorrow.